All right.
Spotlight.
Okay. First of all, everybody tonight, my name again is Dave Fuller. I give this presentation, I don't know how many years I've given it now, probably 7 or 8 years worth of giving this presentation, and I've added to it over the years, and I've taken some stuff away over the years. One of the other volunteer hats, well, I wear volunteer hats in several organizations, but one of them is I teach classes for the Coast Guard. And this material that I'm going to present to you tonight is just about this much of the class that I teach, weather class to the Coast Guard. It's about a 40-hour class, okay? And I'm just giving you the 30,000 foot level, the high level, big picture stuff. There's no way any of you would be awake beyond about 2 hours if I gave you the complete course. So it's a pretty brutal course, and it's very difficult to pass. You're not quite a meteorologist when you're done with it, but you've taken some of the same information that people that do that for a living know. I am not a professional meteorologist. I am a weather enthusiast, I guess is probably the best way to say it, but I've learned a lot over the years. My co-presenter tonight had an emergency at work, and he is unable to join us tonight, so unfortunately you're going to miss a real important part of the program that I had planned. Hopefully we can do it maybe another meeting somewhere in the future, but I'll get to that in just a minute. So Dan was the other person that was supposed to be here, and unfortunately he wasn't able to make it tonight. So, okay, so what we're going to talk about tonight is, what are the factors that cause weather? And this is the big overarching picture. Recognizing signs of change. Why is that important? Because we need to be able to react to those kinds of change. Obviously, you can tell a lot by looking out at the clouds, and we'll go into that here in just a little bit as well. What are some of the signs of bad weather? Now, I think most of us know what some of the signs of bad weather are, but I'll review those for you. We'll talk about reportable weather events. Since most of us in here are ham radio operators, there's a criteria that the National Weather Service wants us to use for what's a reportable event and what's not a reportable event. And I'll get more into that in detail when we get down to that section of it. And then repeater usage during events. Talk a little bit about that. And then some contact information and resources. Now this presentation will be made available on our website. I'm going to send it to Larry, and Larry will be able to post it on the website, so you're welcome to grab that and look at it yourself. It'll have the resources and so forth in here that you'll be able to click on. Okay? So how does weather start? Well, it has to do with heating of the earth. And the heating of the earth is very uneven. Depending on what area is involved, water absorbs heat a lot slower than does land. And there's other forces involved here. But most of your weather is all driven by heat. And what you got to remember is the sun actually heats the earth and the earth heats the air. There is some heating of the air going on as the sunlight passes through it. But the majority of the heating comes from the sunlight hitting the earth and then reflecting up into the air. Now, some of the physics involved here, warm air always rises. And by rising air, it creates low pressure. Okay? Conversely, when you have cooler air in the upper atmosphere, it falls. And when it falls, it creates high pressure because it compresses. The weight of the air presses down and it creates higher pressure. Another thing you have to remember is air always flows from the highs toward the lows. And that's one of the factors. There's other factors, but that's one of the major factors in what creates wind, is air flowing from highs to lows. And of course, the greater the pressure differential, the stronger the wind is. And this afternoon we had some pretty strong wind because of the pressure differential. Now, humidity. Why is humidity important? Anybody tell me why humidity is important?
You'll get wet.
The air would be denser, wouldn't it? If more humid air would be a denser air.
Well, warm air holds more moisture than cold air does. So it's part of why. Well, I'll get to that thought in just a second here. So the relative humidity, you hear them talk about what's the humidity level. It's the amount of moisture in the air compared to the amount of moisture that parcel of air is capable of holding at that temperature. Okay? Now, if you cool air to its dew point, that creates 100% relative humidity and the air condenses out. So that's why you see the dew on the grass in the morning. It's because the air has cooled and the available moisture in the air has now condensed out. When you have a cold glass or something, you see frosting around the edges, and that's because the cold has condensed the air, the water vapor in the air, and condensed it. That's what clouds are made out of, condensed water droplets. Because as that moisture goes up in the air, it cools as it goes higher in the air. And Brian can tell us exactly what that lapse rate is, but I think it's, with it, 2 degrees per thousand?
It's
2 degrees centigrade per thousand?
2 degrees per thousand.
2 degrees centigrade per thousand. So at 2,000 feet, it's 2 degrees colder than it is here. And
You
so
can tell
forth
at
and
what
so on.
level with the dew point and the spread, you can tell how high the clouds are.
Right. Exactly. So, and I told you when we first got started that water gains heat slower than land does, because water is denser, and I think it's about 7 times denser, and it gives up its heat 7 times slower, and it takes up heat 7 times slower. It gives up its heat, yeah, it's 7 times different between land and ocean. And of course, it loses its heat a little bit slower as well. That's why if you go up to the Great Lakes, even though they got cold air blowing across the Great Lakes in the fall and the winter, the lakes aren't frozen over until late December, early January. And the reason for that is because they've got all this heat in them, and the air has not been cold enough to freeze them. It's also why Buffalo gets so darn much snow, because the cold air blowing across the lake picks up that moisture and it condenses out as soon as it gets out over land. But while it's out over the lake, it doesn't do as much. So let's say you're down in Florida, and a lot of you have been down there, and a lot of times when you're near the ocean, you'll have a sea breeze. Why is that? Why do you have a sea breeze near the ocean?
With the temperature difference between the land and the water?
Yeah, but what causes that?
I don't know.
All right, what causes it is in the morning time, the temperature is relatively the same over the ocean and over the land. But as the daytime goes on and the land heats up, that air rises up over the land. The peninsula of Florida is just a large-scale vacuum cleaner. And basically it sucks air in from both sides, from the Gulf of Mexico and from the Atlantic. And air just flows in from the bottom to replace all the air that's moving its way up. It's rising because of warmer air rising. So then all of the moisture and the air comes in, so that's why you have a sea breeze. At nighttime, it reverses. As that air starts to cool, it sinks back down, the wind reverses and it goes back out to sea. And that's when you have a land breeze, that it goes back out, okay? And that's why you have big thunderstorms in the middle of the day in Florida, because all that moisture gets sucked in, it goes up, it condenses, forms clouds, and it rains. That's the mechanism that makes it happen. And just what I just said there. At nighttime, it just reverses.
Is that why it rains then down there in Orlando about 3 o'clock in the afternoon?
Every
day,
afternoon.
Something like that?
Just like clockwork.
Okay.
You almost set your watch by it.
Thank you.
That's exactly why it does.
I lived in Denver for a year. You could set your watch by the rainfall there at 3:15 every day.
Well, and you've got the mountains is what the problem is in
Yeah.
Denver.
Yeah,
Or not the problem, but that's the driving force.
never missed a day.
Yeah.
For about 10 minutes it rained.
And I'm getting ready to talk about that here in just a second. So in the northern hemisphere, with the Earth's rotation, and it's a lot more complex than this, but I'm going to try and make it as simple as possible. The Earth's rotation in the northern hemisphere, the air will bend to the right. The air motion will bend to the right. Okay? So the air that's in a high pressure system will bend to the right and cause a clockwise motion. Same thing if you ever went to the southern hemisphere and flushed the toilet, the toilet water goes the opposite direction that it does in the northern, above the equator. So, and air rushing into a low pressure area, it rises and bends to the left. Okay? So if you think about a hurricane, which direction is the circulation of a hurricane? Counterclockwise. It's bending to the left. Okay? In a high, it bends to the right. And that's what it looks like. So a high is this right here, bending to the right. A low bends to the left. These are basically called isobars. These are lines of equal pressure here. These lines right here are lines of equal pressure. So where these are more tightly packed, you have greater wind. Where they're spread apart further, you have less wind. So it's like a funnel effect in between the high and the low. Now, if you have, well, I thought I changed that slide, but I guess I did. Okay, well anyway, how do you know where the high and the low's at? All right, this is the quick and dirty and easy way of finding it. Let's say the wind's blowing from this wall toward that direction, okay? So you turn to your back square to the wind. Turn to your right 45 degrees, okay? And the high pressure system's over here, and the low pressure system's over here. Low is here, high is here. Now, if the low is to the left, is to the east of you, that means bad weather's past. If the high is over here to the west of you, that means better weather's coming. Okay, if it's the other way around, let's say that the wind's blowing from that direction, and I'm facing this way, and I turn to the right 45 degrees, and over here is low, over here is the high, and let's say that's west, that's low pressure, we got bad weather coming our direction. So that's a quick and dirty way of finding out where's the low pressure, where's the high pressure. It's called Bies-Ballard's laws, okay? That's just an easy, quick way of doing it. All right, talk about cloud formation. This is the real key to determining what kind of weather you're going to be looking at in the near future. So here's the basic cloud types, and I'm not going to go through each one of these clouds here. But let me just say that, and I'm going to zip through the next few slides a little quickly. When you have clouds that are horizontal, clouds with horizontal formation are generally rain clouds, okay? Clouds that are puffy like this, those are fair weather cumulus clouds. Those are mid-level cumulus clouds, nothing to worry about. It's when you start getting clouds with vertical development, like these, that's the ones you got to worry about. All right, this one's called a towering cumulus, and then that's the cumulonimbus. That is where the big thunderstorms happen. Now, if you'll notice the altitude here of these, you'll notice that they consider low clouds anything below 6,500 feet. Okay? Middle clouds are 6,500 to 20,000 feet. They're mid-level clouds. And then the upper level clouds is above 20,000. Now, some of these cumulonimbus clouds can get up to 40, 50,000 feet, Brian, am I right?
Oh, yeah.
And things get really interesting when they get up
Your
there.
conventional airliner cannot get across the top of it. They're only allowed to go to 41,000.
And when they get up that high, you're gonna have a bumpy ride.
Yeah.
And this right here, basically this shield, this anvil, what's happening is that's getting sheared off at the top. There's a river of air up there just working like a knife to cut the top of that thing off. But every now and again, you're gonna see like a little bump on top of this thing right here, which is the updraft trying to break through the top of that thing. And if you see a cloud that's got a flat top on it and it's starting to bubble out the top, there's some powerful updrafts happening inside that cloud. Okay? So, cloud families, again, high, the cirriform cloud, greater than 20,000 feet, the middle clouds 6,500 to 20,000, and then the low clouds are below that. So I'm just going to go through these real quick because I don't want to go through the whole thing on clouds. Now, I could spend an hour just on cloud, the types of different clouds. But your stratus, the ones that have horizontal development are the ones that are rain clouds that aren't threatening. That's like an all-day kind of a rain type cloud. These are a combination of ice and water. And when you get up in here, that's pretty much all ice crystals up there. Cumulus family, you get the cotton balls. No precipitation really out of those. Those are just fair weather, nice day kind of clouds. And then the towering cumulus. This is telling you when you have vertical development, it's telling you have a deep layer of unstable air that's allowing vertical development to happen. And that's where thunderstorms come from. And then the cumulonimbus is where the really nasty stuff comes from.
The thunderstorms are the ones that you don't want to be operating your HF antennas, your flat tops,
Well, there's more activity going on in the cloud,
Yeah.
including lightning and high winds and all kinds of stuff, which I'll get to in just a second. All right, so what are some other things we have to contend with? Well, one of the most important things that drives a lot of our weather around here are cold fronts and warm fronts. And what is a front? A front is defined as the zone between two different air masses. And they're defined by the differences in temperature, humidity, the wind direction and speed, and what the air pressure is. And obviously, that's going to affect what the weather's going to do. So when you have a cold front, that means there's a mass of air that's cold that's moving in a direction. And it's trying to push the warmer air out of the way. And I'll show you a little graph here in just a second to kind of help make that point a little bit for you. Cold fronts move much faster than warm fronts do. They're much faster moving. They are probably responsible for more violent weather than any other kind of frontal. And when they pass, it's just like a wall. The pressure is a certain pressure, and then it goes up pretty abruptly when the cold front comes in. The temperature will fall pretty abruptly. Your relative humidity decreases because remember I said warmer air holds more moisture. Colder air can't hold as much moisture, so there'll be a drop in the humidity, and the wind will shift direction. So here's kind of what it looks like. If you can just picture, you got this parcel of warm air out here, and here comes this cold air, and it's trying to squeeze underneath this thing. Because it's cold, it's going to go underneath. Remember, warm air rises. It's naturally more buoyant. Cold air sinks. So as this cold front comes in, it's having to push this warm air out of the way. So it's going to try and squeeze in underneath it. Well, when it gets over here with this clouds, it's got all this moisture in it, it's going to be just like wringing out a sponge. And that's why you get this rain, because it's squeezing the available moisture out of that cloud. So here's kind of the sequence of events when you have a cold front. So you get the cirrus and the cirrocumulus, altocumulus, cumulus, towering cumulus, and cumulonimbus. And I think this shows, yeah, 20 to 30 knots is the advance. And you could have a squall line 50 to 100 miles out ahead of the front. That's not uncommon at all. And that kind of gives you a rough idea of where these cloud families, you're going to see the cirrus clouds about 200 miles out, altocumulus 150, cumulus about 100 miles out, 50 miles out you're starting to get towering cumulus. And then where you are, where the front is, just directly in front of the front is going to be the towering cumulus, and then the cold front's back in this area here. Warm fronts, just the exact opposite. Warmer air is behind it. They're much slower moving. They don't have violent weather associated with them. It's real common to get nighttime fog with a warm front. You can have long periods of rain because they're so slow moving, and they do squeeze some moisture out of the atmosphere. There's not a lot of pressure change, and there's not a lot of temperature change when a warm front comes through. So again, here is the cold air that's in place. It's on the ground. It's trying to stay down here. You got this warm front that's coming in. And remember, the warm air is more buoyant. So as it comes in, it's just going to kind of slide right over the top of the cold air. And as it does, again, you've got that squeezing of the sponge that gets the available moisture in the air, squeezes it out. And you can see how much more, instead of the cold front was pretty vertical, pretty abrupt. You see how long and tapered this is. So that's why long periods of rain are often accompanied with warm fronts. And you'll see in this one that the scale is quite a bit different. It's much further. It can be as much as 1,000 miles out when a warm front comes in. So it's quite a bit of difference. All right, thunderstorms and tornadoes. And this is where I wish Dan was here tonight, because we're going to miss the part that he was going to do. But Larry was kind enough to help us out with saving me on a screen capture he's got, and I'll switch to that in just a second as soon as we get to that slide. But for severe weather, you have to have 3 essential ingredients. Essential ingredient 1 is you got to have moisture. Without that, nothing happens. You have to have a latent heat source. You have to have surface dew points above 60 degrees. You have to have lift, all right? You got to get something to get that motion going upward. It's got to start moving up. So you got to have lift. And where do you get that from? Well, you get it from frontal zones. When you get a front come through, that provides that lifting mechanism. Orographic lifting. Who knows what orographic lifting is? You can't say.
Oh, come on.
Explain why Brian can't say that to
Oh.
folks that don't know him.
Brian is a professional airline pilot. He flies jets for a living.
Through the weather.
Through all this stuff. So, what is orographic lifting? Was it Marvin?
Yeah,
What is orographic lifting?
haven't a clue.
Well, you were just telling us about it a little bit ago.
What about Denver?
Yeah.
What's in Denver?
Mountains.
Orographic lifting, terrain. So when all of this moisture bumps up against a mountain range, what happens?
It's gotta go up.
It's got to go up, doesn't it? Okay. You know how the meteorologists always talk about we're getting a wedge here in Atlanta? It's that cold air that's being funneled down along the Appalachian Mountains. It's actually like a funnel to funnel that cold air coming off the North Atlantic, funnels right down into North Georgia. That's orographic lifting. Okay. It's a mountain range. It's buildings. It's big things that create lift. And you can have converging winds at low level, and you can have diverging winds aloft. And I'm not going to get into a long explanation about that because I could talk for an hour just about those two subjects. And you can have intense surface heating as well. And of course, Brian will tell you if you're out flying across the desert in the middle of the day,
Parking lots,
parking lots, yeah,
when you're low, it'll affect you quite a bit, yeah.
kind of bumpy. Okay. And the third ingredient you gotta have, none of this happens without instability in the atmosphere. And how that works is you gotta keep these updrafts in motion. And if you can't sustain that lifting, you can't allow that upward momentum to keep going. If you got something blowing the top of it off, it can't develop, it can't go any higher. The higher it goes, the more power that it's got. Okay? So, I'll tell you a little bit about thunderstorms, when and where they form. And this is kind of an old graphic. I'm not really sure if it still is really valid anymore because I don't have the data to go with it, but it kind of illustrates months of December, January, and February. You know, that's the kind of the focal point. We have a lot of thunderstorms. And look how that grows in March, April, and May. Okay? And then, golly, June, July, August, you got, you know, way more than half the country involved in it then, including some areas really strong, which is basically bumping up against the Rocky Mountains. And then, of course, the southeast U.S. and all of Florida. And then September, October, November. Again, the Gulf Coast area is kind of a hot spot. And surprisingly, this area right here of the country, this doesn't surprise me at all because you got the desert southwest. But it's kind of odd that this is this far north and not down in that area. But yes?
That's what's known as Tornado Alley.
Yeah. And usually, well, it could be because you still got, primarily, you got warm, moist air coming up out of the Gulf, and now you're starting to see in September, October, November, you're starting to see some cold air come down from the north, and where those two masses collide, that may be why you got more of it there. All right, thunderstorms and a squall line. So here's the stages, the three stages of a thunderstorm. You start out with the building phase right here, and this is mostly updrafts. This is a big vacuum cleaner. It's just sucking air in. It's all of this air is warm and moist, and it's taking the elevator up. Okay, it's all sucking in at this point. It's growing, and if you see a cloud like this, you can actually sit back and watch it. You can actually watch it grow. I've sat out and watched them where they actually grow.
Now, that would also carry ice crystals up and make hail out of them.
Well, I'll get to that in just a second. Okay. The second stage is the mature phase. And that's where now you've got all this instability. You've got this freight train going up. All right. Remember, down here it's warm and moist. Up here, the higher you go, the colder it gets. Okay. And as the air gets colder, it condenses. So you've got all these clouds. At some point in time, when it gets up to a certain altitude, it's going to run out of power to keep growing up. So once that occurs, when it gets to the mature phase, now you're starting to get some downdrafts. You're starting to get some air that's now cooled. Down here it's warm and moist. It's still sucking in warm, moist air from all around it from the sides. And there's still a little bit on these edges that it's sucking in. But now the core of this thing is starting to get cool. So now you're starting to see some downdrafts occur. Okay? And then the final phase, it quits sucking stuff in. Now it's all a freight train going south. That's all dissipating in the third stage. So, again, mostly updrafts in this phase of it. It's still sucking some air in. And there's a mixture. And if you look at the leading edge of it, the movement in this storm is moving from left to right. in the mature stage. And you'll see the top of this thing blown off toward the top, and if there's an anvil, the anvil is going to be out here because it's being blown off. Okay? And there's the anvil. You see how the anvil is formed up here? It's basically, just think of it as a knife that's cutting off the top of the cloud. And at that stage, everything's coming down. That's when you get microbursts. Okay? People think they're tornadoes, and they have the same force as a tornado. Because that air flowing down here can do well over 100 miles an hour coming out of that thunderstorm. So, and again, you still got as all this air comes down, notice how when it hits the ground, how it starts to spread out? That's because, quite frankly, it's got nowhere to go. It's now, all this air is coming down, it hits the ground, it can't go any further south, so it's got to start spreading out.
Hey, can you back up one slide?
Sure.
Maybe it was two. Back up one more.
One more.
Okay. So that picture shows the updraft coming into the back and downdraft out the front with movement to the right.
Yeah.
Now go forward to your slide. Another.
To that one?
Yeah, now your updraft's on the front side, but your movement's
Well,
still forward.
it's still going to be sucking air in from over here because this is a warm, moist sector. This white area is all cold air that's come down. This is all still warm, moist fuel, so to speak, that is still sucking it in on
They
the
can do
sides.
it from either side.
But the core of it's cold. The core of it is cold, and the air is coming down. So there could be some updrafts on the outer edge of it, but the center of it is cold, and all the air is coming down. And Brian will tell you that's not the kind of thing you want to fly into.
be.
Huh?
That's not where you want to be. That's otherwise known as wind shear.
Yeah.
Mm-hmm. You have rapid changes of wind. If you're coming from the right going to the left, the aircraft has an increased performance. But when it goes through and comes out the other side,
Right here?
it shears to, yeah. If you're coming toward
Right.
Dave,
You're
it's
coming
right.
here. You've got whatever the airspeed is plus that wind speed. Then you get here. Now it's trying to push you to the ground, and when you get over here, now it's not only trying to push you to the ground, but now it's taking away your forward speed. That's a real bad place to be in an airplane.
Especially
close to the ground. Close to the ground. All right, so, and what he just said right here, wind shear turbulence. So what a lot of times you'll get when you get a big thunderstorm, you know how when you get that first gust of wind where it gets real cold? That's what this thing here is, the gust front out in front of it. That's kind of the leading edge of that wind shear area where all that cold air is coming down and away from you. And how you know which way the storm's moving, oops, back up. Look at that anvil. Which way that anvil's going is which way the storm is headed, okay?
Is that the stratosphere winds that, the high winds that,
Chances are that high view would be dealing with the jet stream. Where you,
the jet stream, that's what I'm referring to.
summertime,
whatever
the jet
winds are
stream
off.
stays a lot further.
Or you could just have high-level winds, not
Oh, yeah,
necessarily
yeah.
jet stream, but you could have high-level winds.
But in the wintertime, the winds are a lot higher in the jet stream, anywhere from 150 knots.
We used
200
to, when we went to Athens, Greece, we'd get up there and we'd have 125-mile-an-hour winds or so forth behind us. But we'd get in there early. Going
Oh, yeah.
the other way, you about run out of gas.
Yeah.
Sorry about that.
All right, and then you get into a roll cloud here, which is kind of how a tornado starts kind of to form. And I'll get into that here in just a minute. Usually it's on the back side of the storm, though. It's not on the front side. But you can get a roll cloud to get rotation going. All right, when you get a microburst, when this air is coming down like a freight train, when it hits the ground, it's going to spread out in all directions. So if you see a pattern that is just a big circle and everything looks like from the center, the damage is out from the center, That's a microburst. Okay? But a microburst can do just as much, if not more damage than a tornado can. Because it's doing 100, 120, 130 mile an hour. You know, and a weak tornado might be 90, 100, 110 mile an hour. So you don't have to have a 250 mile an hour tornado.
It's also a bigger footprint than a tornado footprint.
Much bigger footprint. Now, you know, rare is a tornado that's more than a half mile wide. And mostly they're quarter mile and smaller as far as the width, but you know, there has been some big ones. So that's called a mamatocumulus. And what that looks like is a pot of boiling water turned upside down. And if you see that, I got to tell you, there's some real instability on the other side of that cloud. Kind of looks like boiling water. So be on the lookout for bad weather if you see something that looks like that. All right, this is something Dan gave me for the presentation, and it's a number of severe weather days per year, and you can see that we're kind of in the middle of some of the hardest severe weather days where we're at. Severe hail days. And again, if you look at this area of the country, you know, say Tornado Alley, that's part of that is because the Rocky Mountains is actually channeling that cold air that's coming down out of Canada. You got the warm air coming up out of the Gulf of Mexico where the two clash. That's the natural result of what happens.
So are you saying that when you get out here in the west, or like in Nevada,
The other side of the Rocky Mountains,
you don't have any hail out there?
well, they have hail, but it's not nearly as common.
Sure. Oh,
It's pretty rare.
wow.
Pretty rare out
That
there.
was another thing about Denver, they had a lot of hail.
Yeah, because you're right on the edge of the mountain.
The
You're
day
on
I
the eastern-
moved out there, they had 3 foot of hail.
Oh,
Yeah. You're on the eastern edge of the mountains.
Yeah,
wow.
it was very local, but it was 3 foot.
I lived in Utah for 6 years, I don't remember.
Wow.
Little piece on it.
Yeah. And then there's the severe thunderstorm wind days per year. So again, we're kind of in the heart of the area that we're going to get impacted quite a bit. All right, here is, this happened on just recently, Coleman, Alabama.
I never saw it, I was in the basement.
Here's the line of supercells. And I wish I could slow this down, but I can't. If you look over here around Coleman, when it comes back around, I'll show you again.
When you say a supercell, what defines a supercell?
It's the height of and the intensity.
Of the cumulus?
It's the height of it plus the intensity of the precipitation.
Oh, wow. Okay.
Now, if you look over here, the storms are merging. Right, that spot right there. You see this pink color that was right here? That was the tornado.
Wow.
Okay. Now I got a better one than that because Larry saved it. But before I show you that, let me show you the guy who found something that's really amazing. And right there it is. That was the tornado. I don't have any way of stopping that thing, unfortunately. That guy is a reporter for the Coleman Tribune, and that is one of the hailstones he found in his front yard
Wow.
from that storm.
I saw a hailstorm on the internet the other day. You could just watch the car windows just get torn out. The cars just melted down. I mean, they were just beating it
Right?
in.
So they weighed this thing,
Wow.
okay?
Blowing.
And there's the measurement on it.
Wow.
5 inches.
Yeah. So it was 5 1/4 inches in width. It was 13 3/4 inches circumference, weighed 8.9 ounces. So they don't have an official hail record for Alabama, but the biggest one they found was 4 1/4 inches. So I think that was probably going to be, once they certify it, it'll be probably the biggest hailstone that they ever found in Alabama. So the largest ever recorded was in South Dakota, was 18 inches and 1.93 pounds. That would hurt.
In circumference, that would be,
That could kill you.
yeah, it would.
That is just amazing.
Well, they showed a bunch of sheep there on the internet where they're all dead.
Knocked them all
Yeah,
out.
yeah. All right, well, thanks to Larry, I'll show you what a tornado actually looks like. And I've got to back out of this, so bear with me just a second. We got fire alarm, okay?
While you're working on that, is the green stuff coming at the radar and the red is away, or is it vice versa?
Green is toward and red is away.
Well, that's where those real wind shears hit too, and that's where those,
There you go.
where you got the green and the red
Were you,
come together.
Dave, were you adding the toward miles per hour with the away mileage per hour for a total velocity?
Right,
There you go.
okay,
So you can see it right there.
all right. Anybody see it?
That little blue spot.
Right there. You know what that is? That is the debris field that's kicked up in the air. So what you're looking at is and the scale's not on here, but there's a scale on the side of it that tells you that the different colors, depending on what color green, what color red, the darker the red, the faster it moves, the darker the green, the faster it moves. But when you see a blue right in the middle, you got red, you got green, and you got blue in the middle. That's a debris field that's kicked up in the air from the tornado.
Channel 2 announced that when they were showing their
And see how long that was on the ground? Run that loop
Yeah,
again.
it's a 30-minute loop.
Look at that thing. Look how long it's on the ground, clear all the way over here. So it was kicking up a debris field the whole time.
Yeah.
And you can actually tune the radar to the darker the color blue,
The more debris.
start about right, see if you can stop it about right there. A little bit further. A little bit more. Whoa, right there. You see that pink right there in the middle?
yeah.
That's big pieces. That's like car-sized pieces.
So what you're saying, that's Jack State University in there.
That's like the movie, that's cows. That's pieces bigger than cows flying through the air there. That's big pieces of building.
Cow, the boat and the
And
trailer.
that's-
Cows, boats, trailers.
You have to keep in mind is how far away this is from the radar. That's it, I think I measured it, and it was about 2,500 feet was the lowest the beam was getting right there.
So
that's way up
that's,
in the air.
that's it's seeing that
Wow.
at 2,500 feet in the air. So what's that mean, what's that debris ball look like on the ground?
Now, how can you tell that's 2,500 feet up?
Because you measure from the radar site.
Yeah, the radar beam will only go so, well, you know, curvature of
It's,
the earth. and
it's,
everything.
well, no, it's a straight line.
Well, the radar.
Yeah, the radar's straight line.
Curvature of the earth.
But with the curvature of the earth, basically, if you're standing at this height, the horizon is roughly 6 miles away.
So you're measuring from Peachtree City?
Yeah, this program's got well, it doesn't show it on there, but you got a button you click, and you pull a little cursor out, and it'll tell you
It'll
exactly
tell you
how
exactly what the
high.
mileage is, how many miles it is from the radar site. And from that, you can extrapolate how high in the atmosphere it's looking. And then it's also got different tilt angles of the radar, so you can see at different levels of the
Yeah, I
atmosphere.
think it was down at the bottom is at 0.5, which is as low as
That's
it
as
would
low
go.
as it'll go. Yeah.
This is part of that radar scope pro.
Right.
Yeah.
Is that
Which-
ADAP or is that green?
No, that's paid. That's not free.
Yeah, you gotta pay for it.
That one's not real expensive.
No, it's
No, it's
not.
not, it's pretty cheap. You can get it for iOS or whatever, and Android, I think, too.
Yeah, it's not that expensive.
And you can pay more for higher detail information.
Right. Talking about the height and the radar, we saw this when we, the club, some of us went through the National Weather Service at Peachtree City. What was that, Larry, about 5 months ago?
Yeah, it was November.
And we probably should do that again, don't you think? It was interesting.
Of course, this time of the year might be hard to
This
say.
is kind of, I was gonna say, they're probably pretty busy right now.
Well, maybe like October.
Yeah, late fall, yeah. Anyway, thank you, Larry, for doing that. That is just amazing. And had Dan been here tonight, he had the whole thing that we could have done.
What is the green thing down there at the bottom of the picture?
It's a tent.
It's what?
Yeah.
Is that the one?
Yeah, it's being beamed up.
It's $10 for that, and you get regular rate. You get higher.
That goes back a few years, doesn't it?
Yeah, you did get a good shot like this.
That's one of his buddies that got cake rice.
Molecule.
Yeah.
Okay, let's see if that's, all right, so it works. All right, so back to tornadoes again. And this is something, a slide I put in last year, is the average number of tornadoes per state per year. And it's amazing, Mississippi and Alabama are pretty high, but look at Texas.
More real estate.
I know they got more real estate, but look at the numbers. Look at Oklahoma, look at Kansas,
Yeah,
Nebraska, Colorado.
there's Tornado Alley right there just in display.
Yeah. So,
It's amazing, this Iowa.
It's scary in a tornado, I know.
Oh, yeah. We were in one in Omaha, and let me tell you what,
Oh, you were.
two befores came, were coming down all around us. There was a house about 200 feet away. The whole top of it was gone. All the rafters and stuff came down. There was a man holding his baby, and he couldn't move, but he was still alive. And they come and lifted the house, the structure off of him. The baby was unhurt. He wasn't in too good a shape, but he lived out.
That's right, I saw the tornado also.
Yeah,
There's something,
it was bad.
if you've never been in one, there or something.
don't want
In
to
1971, I laid inside a storm drain, and we never found the Jeep. Me and my other guy was riding it
3 o'clock in the afternoon.
on the base in Kansas.
Let's hold on, guys, let him continue here.
All right, let's go back. So here's kind of what a wall cloud looks like. If you see this, and by the way, guys, this is a reportable event. When you see a wall cloud, National Weather Service wants to know about it. And basically what a wall cloud is just exactly what it sounds like. It's a wall. It's straight vertical. When you see something like that goes way up there, remember I was telling you earlier about the overshooting top? When you see this little bubble on top of this thing, that's a clue that there's a large amount of air moving up at a very, very, very rapid pace.
And I'm assuming the direction of travel is to the left there?
Yeah, the anvil's back here, so the wind is blowing the top of this thing off this direction. Okay? But this overshooting top, that is a clue, because just think about, it's like a knife blade trying to cut the top of this thing off, and there's enough oomph going up to make this bubble on top of this, in spite of the air that's probably moving 150 mile an hour going across the top of this thing, and there's still enough oomph to get it out of here. So, if you look, you got this is the back side of the storm, and out in front of it, you've got the outflow coming out, you've got precipitation out here, and you still got inflow on the back side of it. And here's the wall cloud, and if you see the base of this cloud, there's another thing that falls below this, and I've got another picture here in just a second to show what it looks like. But when you see this, that is a wall cloud, okay? And basically what's happening is you see that if there's a twisting motion back here, and actually a tornado starts out as a horizontal spin back, well, actually it's this way, horizontal spin back this direction. And then as the upflow goes, it straightens out that spin and it either sucks it up or it breaks it in half. And then it forms two. So sometimes you'll see two tornadoes, and it's because the upflow has basically broken that thing in half, and now you've got two funnels instead of one. But that tells you that there's a tremendous amount of upflow if you get one that gets broken in half. So this is also known as the mesocyclone. So the tornadoes will almost always be on the back side of, you got your outflow out here, your precipitation, you got inflow, and the tornado will be back in this sector. It'll be in the back section of it. And there's what a wall cloud looks like. You can see that the base of the clouds is up here, and now you've got this thing that extends down below it. And if you look at it, you can see this circular motion. You see that circulation going on there? So that's telling you that there's circulation going on inside that wall cloud. National Weather Service wants to know about that because they may not be able to see this on the radar. What they can see is precipitation. So unless this has got rain coming out of it, they can't see a cloud. They can see the rain. See that rain over here? They can see that. They can't see this. It doesn't show up on the radar. Okay? Unless it's got precipitation flying around in there, and then they can see it. Or there's hail flying around in there.
John's got a question.
Yeah.
That's on ground. Do you ever have that happening over water?
Sure.
Water
Absolutely.
spout.
That's a water spout.
Right. It can happen anywhere. Over water, over land. Anywhere. Now, they say, especially in this area, if you see something that looks like that, we're going to call it a tornado. And the reason we're going to call it a tornado in this part of the country is because we have so many hills and so many trees, you have no idea if that's on the ground someplace or is just above the treetop level. You can't see it. So if you see something that looks like these, call it a tornado. Whether it's on the ground or not, they're going to want to know about it. And there's a water spout over the water. Now generally the ones that form over water are much less powerful than the ones that form over land, but they still can have a pretty good punch. I went through one of those, I'm going to say probably 35, 40 mile an hour winds. But the reason this is so visible and it makes it look like it's a 400 mile an hour tornado, what's it sucking up?
Water.
Water's visible.
I was on one up here on Lake Ellington. It actually started over land, skipped across the lake. And, it was not pretty
No. Boat spinning around,
close.
Sucking fish up.
sucking everything up. But that's the reason that funnel is visible, is because it's sucking water up. It's much more visible. Okay.
That must be why in that movie about what was it, tornado, it was about the tornadoes, and they were putting out a thing out there with all of these electronic devices.
The movie thing, yeah.
Was that so they could see?
Well, so they could measure the wind speeds,
Okay,
circulation.
that makes sense.
All right, tropical weather. Now, even though we're 300 miles inland from the ocean, we still got to worry about that here. We have in the past had tropical storms come right up here and set up here. Right after I built my house, we had Hurricane Opal came up and set right on top of Atlanta, and it rained and rained and rained, and 3 of the trees I wanted my builder to take down came down in the storm. His excuse was things have a way of taking care of themselves. But I was the one out there with a chainsaw cutting them up. But anyway, we do have to worry about tropical weather here, so going to talk a little bit about it just for your information. Tropical depression are defined as winds, sustained winds to 34 knots, 38 mile an hour. Tropical storm is 35 to 64 knots, 39 to 73 mile an hour. Hurricane force is over 74 miles an hour. And then within the hurricane, there is also, other names for hurricanes, depending on what area of the world that you're in. They're called Willy Willies, I think, down in Australia. All right, hurricane categories. Again, tropical depression, tropical storm, and category 1 through category 5. Last year was a really bad year for hurricanes, and the folks in the Virgin Islands and Puerto Rico took the big brunt of it last year. As a matter of fact, Puerto Rico is still not recovering. There's still about 25% of the island that's still without power and running water, even today. How many months has that been later? And it may be another year. A good friend of mine works for the Corps of Engineers. 3 weeks ago, they put the last blue tarp on the last roof that they were doing. That kind of gives you a clue as to how long it's going to take to get power and infrastructure back down there. But they hit it pretty hard. People in the Virgin Islands, they're just now starting to come back. I was reading something in the boating magazines, and a lot of the charter places have come back, and they're trying to get people to come back and be tourists down there. So hopefully they don't have to deal with that this year. So the tropical storm warnings are issued by the National Hurricane Center in Miami. And help me out here, folks. Why in the world would you put your National Hurricane Center
In the middle of a hurricane.
right in the middle of where a hurricane's going to hit? Now, what brilliant idiot did that, made that executive decision at the federal government level? I'd be putting it in Denver, Colorado or something. I mean,
Put it in Nevada.
put it in Nevada, but why Miami?
That's why the National Storm Prevention Center
Is in Norman, Oklahoma, right in the middle of, where they're going to get nailed too. Okay. Same guy made the same decision, I guarantee you. So, anyway, so they issue tropical storm watches. Do you know what the difference between a watch and a warning is on tropical storms?
Conditions are right where you've actually seen one. They be on the warning.
Well, it's based on when it's going to hit landfall. So a watch when it's possible to get landfall within 48 hours, and a warning is when it gets within 36 hours.
Oh, I was thinking tornadoes.
No. And then the Coast Guard will actually close the ports in advance of all these conditions. They have certain set conditions that when there's a tropical weather that threatens, they'll take specific actions to close the ports. And so, very specific things that they have to do. And it's at some point in time, the local authorities will actually close drawbridges and lock them down. So if you're on the island and the mandatory evacuation order is given, and you decide to stick it out, and they lock the drawbridges, you ain't getting out. You are going to stay. So if you're ever in a place that's possible to get one of these things, if they tell you that there's one coming, do yourself and your family a favor and leave. Do not be brave. Do not be stupid. Get out. Okay? Because you are on your own. They are not going to come get you.
They were writing down their names, their social security numbers.
Yep. Put them
Make
on.
sure you write down your information in case that they're gonna come and get the bodies.
That's right. So they know who to notify next to kin.
Quick question.
Yeah.
The tornado rotation counterclockwise is a hurricane clockwise? You said they're
No,
trying to-
hurricane is low pressure, so that's
So it's
counterclockwise. High pressure is clockwise. Yeah, hurricane is low pressure, so it's counterclockwise. All right, lightning. So what causes it? It's basically the friction of raindrops and ice particles in the atmosphere. And well, thunderstorms, you know, they create electrical charge. Now, which is the positive charge? What's in the cloud or what's on the ground?
Ground.
Could be either
Which one's positive?
Right.
Most of the time. The earth is positive most of the time. The cloud is negative. Most of the time. Not every strike, but most of them.
Goes from the cloud to ground.
Right.
Ground level to the positive line.
I would slow it from positive to
So-
negative. It
so
would go
you
from
say-
the ground up.
I'm sorry, so you say most of the time?
Most of the time. There are strikes that come from the ground to the cloud, but most of them come from the cloud to the ground.
So when does that happen? It goes from the ground to?
There are strikes. You can actually
Yeah, I know.
do Google and find
Yeah,
it.
yeah, yeah. I just wonder why.
What causes that? Who knows? I really don't know.
Usually places that have high mineral deposits, of like iron ore or something.
Yeah, could be.
We
Or
have
salt,
electrostatic
maybe salt too.
charges that if you've got an electrostatic charge and if it's negative up here and it's positive down here, the electron flow is going to be from negative to positive. And if it's opposite, then it's going to go from, it will go from ground to cloud. But
All right.
he's right on that. The majority of them are the way.
Is lightning a reportable event to the National Weather Service?
No.
Okay. Why? Why is it not reportable?
Because they can show you, they show it to you on TV. They measure
Well, I thought I recognized that laugh.
it. I'm sorry.
Okay. There's no way to quantify if the severe conditions are not generally shown by lightning. Just because there's lightning means there's a lot of friction. That doesn't necessarily mean there's a lot of air moving and there's a lot of lift and a lot of other things that's going to create turbulent, severe weather. Just because there's electrical activity doesn't necessarily translate to fair city of the storm.
So when the Charles TV station gives all these lightning strikes, that's just embellishment and.
Oh, it's the thing that the TV meteorologists live for. It's another whiz bang,
Okay.
you know,
Drama.
drama.
Charles could take his lightning rod and his voltmeter and he'd go out there and check.
Look, I gave you a hard time, Charles. Okay. Fog, I want to talk just a little bit about fog. Obviously, you've got and this happens in our area more in the fall than it happens in the spring and summer because you got the warm air out here in the Gulf of Mexico, you got the cold air up here. This warm air comes up and tries to, remember I showed you that slide earlier? Warm air tries to override the cold and you get the condensation, and that's what creates the fog. Advection fog is a fog that moves horizontally. So you'll hear them sometimes talk about advection fog, and that's horizontal moving fog. Okay. And then as the sun comes out and warms up that layer of air, then the air no longer condenses the moisture and the fog goes away. So you can have radiation fog, burns off, pretty quick, and usually it gets with little or no wind. If you have a lot of wind, it's kind of hard to get fog. You can have fog with wind, but generally the less the wind, the greater the chance of fog. And again, light winds, warm, moist air moving over colder, and it could last a little bit longer. That's why the people over in Europe, over in England, and the British Isles get a lot of fog up there because you got that cold air, cold water coming down from the North Atlantic over the warmer air that's on the land. All right, I threw this slide in is because we're going to be coming up into some hot weather here fairly soon. And so take a look at this chart. It kind of gives you an idea of what the temperature is. Let's say it's 90 degrees outside and you have a 30% humidity, then it feels like 90 degrees. But let's say you get up to about 60% humidity. Now all of a sudden, it feels like it's 100.
Now, is this similar to the cold temperature,
I'm getting there.
the effect on bare skin?
I'm getting there.
Warm-blooded animal.
Yeah.
Well, that leaves me out, 'cause I'm cold-blooded.
The idea behind this is you can get into this red zone pretty easily and get overheated. Okay? So you don't want to be there. And there's the other side of it. There's the wind chill chart. It tells you a little bit about, you know, as the wind blows more and it's colder, obviously it drops down pretty quick. When you get into this dark blue area over here, frostbite occurs in 15 minutes or less.
Been there.
So, just for your awareness. Okay, so let's talk about reporting events. So we're going to start off with urgent priority first. Obviously a tornado, whether it's on the ground or whether it's aloft, we're going to call it a tornado and we're going to report it as a tornado. Now I'll get to the other things here in just a second, but I want to talk about the events first. It says funnel cloud, but we're going to lump the funnel cloud and the tornado together and call it the same thing. The wall cloud, remember I showed you that wall cloud? Looked like it was rotation. That could be a precursor to tornadoes and funnel clouds. And then of course flash flooding can happen very quickly with relatively small amounts of rain, depending on what the terrain is. You know, and you pretty much know what areas are subject to flash flooding. So be alert to that. But those are the top priority. Those are things that are elevated right to the top of the list. The next right below that would be high priority items. So if you have hail that's 3/4 of an inch diameter or larger, that is a high priority. If you have measured wind speeds, and I know some of us have weather stations at our house, and particularly if you have a weather station and you can say measured at this location, I had wind speed of 67 miles an hour and my equipment is so and so and so and so equipment, okay? All of a sudden you have instant credibility, and that's something that the National Weather Service can hang their hat on. If you have a persistent non-rotating wall cloud, so maybe it's not rotating, but you're starting to see that formation. It could be in 15 minutes that becomes a rotational storm, but right now it's not rotating. It's starting to form, but it's not there yet. And then if you have rainfall, again, measured of an inch or more per hour. I know Ron has had a couple of times, he's reported 2.5 inches an hour when he's had with his measuring equipment. I've heard some of his reports. The lower priority, now don't say that these aren't important because they're all important, but on a list of priority level, these would be the lower priority ones. So if you have hail 1/2 to 3/4 inch in diameter, wind speeds 40 mile an hour or greater, and any suggestion of organization of a storm, and any other local considerations. Now sometimes we'll get a request from the National Weather Service to say, give us a report on what's going on at a certain location. Do you have anybody there? And so they may ask us to put an eyeball out. Now one of the things that Larry touched on a little bit ago is when they're looking at their radar, the further away from that radar site you go, the higher in the atmosphere, the lowest point they can see. So, you know, right down there by Peachtree City, they can see stuff at the same level as the radar. But you get up here, it's about 1,800 feet. 1,800 to 2,000 feet, depending on where you're at. So anything that occurs below that 1,800 to 2,000 feet, they're completely blind to it. They have no visibility on it at all. And they're relying completely on us to tell them what's going on the ground. And that's why spotter training is so important. Because they want you to be their eyes and ears. Because they can't see it. All right, so how big's the hail? Take a look at that list.
Scale. Far. Barbie.
They have a few laughs over some of their
That's pretty good size house.
So what I want to know is that the new thin ones or is that the regular ones?
Double stuff.
Or is that the double stuff one? Yeah.
Suck jawbreakers, that's
Yeah, half as big as the end of my finger. Okay, yeah, that's a good one. So, folks, that's not exactly what they're looking for. That's an example of what not to say to them.
Yeah.
Okay. So here's what we want. This is the basic. Here's what we want to do. What you seen? What was it? What did you see? You saw hail. You saw wind. You saw rain. What was it? If you saw lightning, we don't want to know about it. So forget about lightning. Okay. Where did you see it? What specific location? If you've got a street intersection, don't just give an address and say it was blank, blank, blank address. Say it was close to the intersection of Highway 92 and Due West Road. A half mile west of Highway 92 and Due West Road. That's good enough. They just want to know where this is. Okay? When did you see it? That's really important because you may not, things may be happening pretty rapidly, and the very first thing you've got to do is take care of you and your families, and you got to be safe. And once it's safe, now you can go observe. So this storm might have been 10 minutes ago. So when you're getting the report about what did you see, where did you see it, and when was it, it's not happening now, it happened 10 minutes ago. And that's important that you give that.
I understand they want local time, not UTC.
Now, what, you know, it happened 10 minutes ago, or it's happening right now. That's, you know, when did it happen? Just don't say it happened at 9:02. You know, it happened 3 minutes ago, or 5 minutes ago, or whatever. Now, what was it doing? What speed, what direction, what was happening with it? If you can describe the damage that it's caused. You know, did it rip the steeple off of a church? Did it uproot trees that were 5 inches in diameter? You know, are cars overturned? So, you know, the more specific about you can be about the damage, you know, there's 30 houses that's been destroyed. Or, you know, I got 3 cows in my backyard now that weren't there before. You know, so what was it doing? The more specific you can be, the better off, the better the report that we're going to make it. But if you get nothing else than the what, the where, and the when, that's the 3 most important things that you can give. So repeater usage, we'll have a local net going on the 146.955 repeater, and we're going to liaison that report in. Now, right now, Dan and I have access to NWS Chat. And what NWS Chat is a real-time, basically a chat room where you're hooked up with emergency managers, the meteorologists, the TV and radio people, all the National Weather Service folks. It's a collection of professionals. And when we put something on there, our credibility is on the line each and every time we post something on there. So what we do is we take the reports on the net control passes those on to either Dan or myself, and Dan or myself enters that on NWS Chat. And it's a system that's by invitation only, and they're very, very stingy on handing out invitations on who gets access to it, because they don't want every Tom, Dick, and Harry to be on there. And one of the problems we've had with the linked repeater net in the past is you get all these North Georgia repeaters linked together, and you know, we got tornadoes on the ground and out here in this area, and somebody over in Stone Mountain's talking about, well, it's starting to rain. Well, they've tied up the whole repeater system talking about it raining in Stone Mountain. National Weather Service doesn't care if it's raining in Stone Mountain. They want to know about the tornado on the ground in Polk County. Okay? So that's why we've gotten away from that linked repeater system, and we've gone strictly with the NWS Chat, because that hooks us up in real time with the decision makers that need to know right now. And also all the EMA directors are also on that. So when we're putting that stuff in, they're picking it up off of it right now. They're picking it up in real time. So a lot of agencies listen to that repeater for real-time reports, but the NWS chat is what we've been using now for, I guess, about 3 years, and it's worked out really well because it's kept all the chatter off. You know, we've kind of filtered what we put out there. We keep it short, we keep it sweet, we keep it factual. You know, this was observed at this time, at this location, here's what it's doing, and that's it. You know, we don't have a bunch of conversation back and forth because they don't have time for it. Things are happening rapidly, and they gotta have it right now. And then if you want to call in on the telephone, that's some phone numbers. And again, this presentation is going to be on our website. There'll be times when we don't have a net going, and you might have some kind of severe event. I remember a few years ago they had some tornadoes went through downtown Atlanta, tore up was it a couple of hotels, blew all the windows out. The National Weather Service did not have a net up that day, but we had some of the first reports from out here. Actually, Neil was heading into work and actually gave some of the very first reports. I was in net control that day, and they didn't have a net going down at National Weather Service because I was going to call in on it. So I called this number, and the first time I made the report, I actually talked to a meteorologist, okay, and gave him the report, and he thanked me. He said they were just gearing up because they hadn't, it caught them by surprise. They didn't even know it was coming. So Neil gave me a report about 10 minutes later. I called this number a second time, and I got sent to voicemail. And then later on, next day I called him and said, hey, did you get my other message? He said, yeah, we got it, but, you know, we heard what you said, but, you know, we left it on the voice recorder because we were busy doing other stuff. So they didn't pick up the phone the second time, but they heard exactly what I told them, which actually got them, that report that Neil gave us and the report that I sent in actually caused them to put up a tornado warning for downtown Atlanta. Because of the reports of the weather that was coming in from our direction. And then I mentioned the NWS chat. Dan and I are the only two here, along with the EMA office. They have access to it as well. And when we have a liaison with other counties, generally we have a net control and then somebody else is assigned to be liaison. So we may have somebody assigned to say, listen to the Rome repeater, or listen to the Carrollton repeater, or listen to whatever it is, wherever this weather's coming from. We may have somebody go out and just listen to that repeater. If they got something to report, bring it back to our net. And so that helps as well. And this last round of storms where we had these tornadoes come through, they were looking for some reports from Alabama, and we couldn't get anybody in Alabama.
Yeah, they shut down. The state of Alabama is on D-Star on reflector 58 Charlie. The state of Georgia is on 30 Baker on D-Star. They stopped talking immediately after that report was sent out because they were afraid of looters in the area, and that's why they went radio silent.
Now remember, they were also looking for reports from Haralson County.
Yeah.
Now, does that mean we should have ideally two 2-meter rigs? One for 955 and the other one to monitor?
Well, no, what we would do is we would assign somebody to monitor whatever that other frequency is. Say, hey, listen for a repeater in Carrollton or whatever, whoever would be using that
Then they need
repeater.
another.
And then if you get a report, then come back to 955 with the report. So you could switch back and forth, or you could just have two radios.
Yeah.
That's a possibility. All right, additional training. I'm getting real close to the end here, folks. These are your links. The National Weather Service, traditionally, not this time of year because they're real busy with stuff, but they do spotter classes from time to time, and if we have enough interest, we can actually request them to come give us a spotter class. And I know that Paulding County has asked for that probably a half a dozen times in the last 10 years. And we could certainly drum up that idea maybe later this summer or this fall. Maybe we could request another spotter class, okay? But this time of year, you're not gonna get one because
When you
it's just so
say
busy.
spotter class like Skywarn,
Skywarn, right. They have a basic spotter class that they come out. They also do an advanced level class, but generally those are offered online or you can get on a webinar. Last one I took was about 2 years ago. It was by the National Weather Service office in Tallahassee. They had a webinar that I participated in. And it had been about 5 years before that since I'd taken it before, so it was a good refresher for me. So anybody that's had the spotter class training, I would recommend taking it again because like any other skill, if you don't use it, you lose it. And getting refreshed is a good idea. So, and for you CERT folks, if they haven't gotten you a spotter class, I'll be real surprised if they're not working on that now. And you might mention that to Mr. Dooley,
Okay.
see if he can hook something up.
The group already, there was a group of SART members that already did that course.
Mhm.
But I'm pretty sure they're gonna have another one.
about a year ago, wasn't it?
Yeah, the parks.
Yeah.
Out there, dump
But
spot.
But quite frankly, they're not going to do it this time of year because this is their busy time of year, so they're not going to do it this time.
Maybe summer. or-
Yeah, summer or fall. That's generally when they do it. It's late summer, early fall. And then the spotter page, that's that. And then the spotter's field guide, there's a real nice field guide there on some of the stuff you ought to do. And then Vortex Southeast, that's a really a neat project. It was funded by a grant from NOAA to do some severe weather science, basically. And that's the Project Vortex. If you want to go get fascinated by some of that stuff. Websites, FFC is Falcon Field for National Weather Service Peachtree City. And then skywarn.com, forecast information, that's their number down at Peachtree City. So in summary, talked about what causes it, recognizing change, weather and clouds, signs of bad weather, reportable events, and repeater usage during events, and the contact information. So that's it, folks. That's all I got for you tonight.